My dear students, let me welcome you all to a new edition of physics. In this edition, we'll learn about helium neon laser. We'll learn about its structure, its mode of work. Also, we'll be able to learn about laser applications and uses. So let's get started. Helium neon laser. Okay, so we'll start talking about helium neon laser. First of all, construction of the device. Construction of helium neon laser. It consists of a quartz tube, glass discharge tube filled with a mixture of helium and neon in the ratio of 10 to 1, okay, at a low pressure, and you should memorize the pressure. It is 0.6 millimeter mercury. So we've got a mixture of helium and neon. At both ends of the tube, there are two mirrors, two plane or concave parallel mirrors denoted by M1 and M2. The two mirrors are perpendicular to the axis of the tube. One mirror has a reflection coefficient of nearly 99.5%, while the other is semi-transparent with a coefficient of 98%. And what about, yes, accomplishing the pumping process? High frequency electric field feeding the tube from the outside to excite the helium and neon atoms. So, yes, pumping is accomplished by using high frequency electric field or DC supply, high voltage, or a high DC voltage inside the tube causing electric discharge. And now talking about the operation of the device. In front of you, we've got the 4-energy scheme used in production of the laser. Talking about helium atoms, we've got 2 energy levels. The ground state denoted by E0 and the metastable energy level denoted by E3. Okay, when pumping occurs, when pumping is accomplished, helium atoms are raised to level 3, E3. Okay, and we've got something very important. Level E3 in helium has an energy of 20.61 electron volt and is very close to level E2 in neon. Level E2 in neon atoms has energy 20.66 electron volt. In helium, 20.61. In neon, 20.66 electron volt. So they are very close. Okay. And when a metastable helium atom collide with a ground state neon atom, excitation energy of the helium atom is transferred to the neon atom. So some neon atoms in E2, okay, spontaneously decay to E1, and in this way stimulating photons are produced. And what about atoms found in E1? They rapidly decay to the ground state. Okay, so once again, we'll take it one by one. First of all, pumping is accomplished by setting up an electric discharge in the helium-neon mixture. Electrons and ions resulted from this discharge collide with helium atoms, raising them to the energy level E3. This level is a metastable energy level. Level E3 in helium atoms, as I said, has an energy 20.61 electron volt, which is very close to the energy level E2 of neon atoms. E2 of neon atoms has energy 20.66 electron volts. So they are very close to each other. Thus, when a metastable helium atom and a ground state neon atom collide, the excitation energy of the helium atom can be transferred to the neon atom. And this way, level E2, energy level E2, becomes more heavily populated than level E1. This population inversion, which is very essential situation for production of laser, this population inversion is maintained because the metastability of E3 ensures a ready supply of neon atoms in level E2. Atoms in level E1 decay rapidly to the ground state, denoted by E naught. Some neon atoms, as I mentioned, in level E2 spontaneously decay, spontaneously fall to photons of energy E2 minus E1, which is equal to h nu. And of course, h stands for Planck's constant. Nu is the frequency of the radiation produced, which stimulates some neon atoms to fall from E2 to E1 before their lifetime is over. Most of the stimulated photons initially produced in the discharge tube will not happen to be parallel the tube axis. Okay, they won't be, most of them aren't parallel to the tube axis. They propagate randomly in all directions and will be quickly stopped at the tube walls. Stimulated photons that are parallel to the axis are made to move back and forth through the discharge tube by successive reflections from mirror M1 and mirror M2, so that a great deal of stimulated photons are produced. In this way, amplification takes place. When radiation inside the tube reaches a certain level, laser light leaks out through the semi-transparent mirror. Your attention, please. Neon in this device is the lasing medium. It is the active medium. Metastables of helium and neon are of very close values, and that explains why they are used to produce laser light. Let me say it again because it is very important. metastable energy level of helium and that of neon are very close to each other. And this explains why we use these two particular gases. Laser is used to produce holograms. Now we are talking about laser applications. Laser is used to produce holograms. What about hologram? They are three-dimensional picture. So once again, they are used to produce holograms. Why? Because laser can concentrate a lot of energy onto a very small area. Laser is very highly intense. This explains why we use laser, in surgeries and in cutting, because laser can concentrate a lot of energy onto a very small area. Laser is highly intense, so laser can be used to drill in metals, even in diamonds. Still talking about applications of laser. Okay, since laser can concentrate a lot of energy onto a very small area, okay, so laser can be used to drill in metals, even in diamonds. Lasers can be used as cutting or welding tools in delicate eye surgery. Lasers can be used as cutting, very sensitive eye surgery. Because laser is highly directional. Laser is highly directional. Spreading of laser waves is almost zero, okay? Divergence is zero. So, because laser is highly directional, laser has military applications, such as precision guidance smart bombs, a laser radar, we call it LADR. Let me say it again, because laser is highly directional, laser has military applications, such as precision guidance and smart pumps and laser, radar. Lasers are used to guide bombs and missiles in recent conflicts. This we call it military uses. They are used, lasers are used to guide bombs and missiles in recent conflicts. Also, laser has applications in art and laser shows. Okay, so we use lasers in shows. Once again, also laser has applications in art and laser shows, surveying, determining dimensions and areas, and space research. Okay, they are used in space research. A long-range communication, laser beams are used instead of electrical signal carrying wires, because signals travel along optical fibers with less loss and are also immune to electromagnetic interference. Also, laser can be used in industry, particularly fine industries. It is used in CD reading and writing. Also, it can be used in laser printing. Your attention, please. Because laser can concentrate a lot of energy onto a very small area, it can be used for cutting, if it is focused with a lens, the laser can cut through metals, such as steel, quite easily. It can even cut diamond. So once again, if it is focused with a lens, the laser beam can cut through metals, such as steel, very easily. It can cut diamond also. Of course, it doesn't really cut. What really happens, laser vaporizes the material, okay, on which it is focused. A laser knife, this is very interesting. A laser knife can be used for surgery. The energy of the light beam instantly boils any cells. Okay, let me say it again. Laser knife can be used for surgery. The energy of the light beam, laser beam, instantly boils any cells on which it is focused. No infection can be caused, and the wound seals under the effect of heat, so little or no bleeding occurs. They are used to adjust the curvature of the cornea to correct defects of vision. Okay? And now let's differentiate between laser light and normal light. How to differentiate between laser light and normal light? We'll use Young's experiment. Okay? In Young's experiment, if a white light is passed through the two slits, an interference pattern of colored fringes is produced on the screen. So, if white light is used, normal light is used in Young's, we expect to find colored fringes. Okay, let me say it again. When using white light in Young's experiment, colored fringes are produced. But when using laser, now if we illuminate the slits with a laser, the interference pattern appears as a set of alternate bright and dark fringes. This is one method to differentiate between normal light and laser using Young's experiment. Second method to differentiate between normal light and laser is using prism set in the position of minimum deviation. Normal light disperses into 7 colors, but laser is made of just one wavelength, so no noticeable dispersion occurs in case of laser, but normal light disperses into 7 colors. Third method to differentiate between, normal light, ordinary light sources, and laser. In ordinary light sources, the diameter of the emitted beam increases with the distance. But a laser, it stays unchanged for long distances without much divergence. And now, let's answer some questions together. First of all, give reason for. Laser light does not obey the inverse square law of light. Let me say it again. Laser light does not obey the inverse square law of light. Okay. First of all, laser light has high monochromaticity. That's to say, it has a very small bandwidth, a small frequency band. Laser light has high collimation. It is highly directional. Laser light is coherent. That is to say, photons of laser light are in phase. So laser is very intense. That is, it doesn't obey, that explains why it doesn't obey the inverse square law of light. Another give reason, laser light is highly monochromatic because all the photons of laser light have almost the same frequency, same energy. It is, yes, E2 minus E1. Each one of them has an energy equal to the difference of E2 and E1, which is equal to h nu. And let me remind you with h is Planck's constant, nu is the frequency. So they've got the same frequency. Having same frequency meaning they have the same wavelength. That is to say, the bandwidth of laser is very narrow. Another important give reason, a mixture of helium and neon gases is used to invent a gas laser. Why helium and neon in particular? Let me say the question again. Give reason, a mixture of helium and neon gases is used to invent a gas laser. Yes, because metastables of helium and neon, metastable energy level of helium and metastable energy level of neon, yes, are very close to each other. Thus, when a metastable helium atom collides with a ground state neon atom, when they collide, the excitation energy of the helium atom can be transferred to the neon atom. In this way, a population inversion situation is obtained, where there are a much greater number of neon atoms in E2 than the atoms found in the ground state. Thus, a stimulated emission becomes predominant and laser light is produced. Give reasons. We want you to explain why we should have two mirrors. Explain the presence of a totally reflecting mirror and a slightly transparent mirror in the helium neon laser. As a matter of fact, the two mirrors lengthen, they increase the path of the stimulating photon to increase the number of the stimulated photons. In this way, the intensity of laser light is built up. Intensity is amplified. Also, the two mirrors improve the spectral purity and the collimation of the beam. Also, laser leaves the device from the slightly transparent mirror. Give reason, high frequency voltage is connected across the two electrodes of the helium neon laser. When a sufficiently high voltage is applied, what happens? Yes, a discharge occurs. Collision between ionized atoms and electrons. Electrons carrying the discharge current excite the atoms to various energy states. Give reason, laser is a very useful tool for surveyors, especially in situations where great precision is required. Let me say the question again. give reason. Laser is a very useful tool for surveyors, especially in situations where great precision is required. Because laser light, yes, has high collimation. It is highly directional. That's to say, the photons in a laser beam are strongly correlated in their directions, and a laser beam can travel long distances without appreciable spreading. In this way, we've come to the end of this edition. Until we meet again, my best wishes.